I'm going to pick up in this video right where I left off in the last one. We solved the first four problems on the worksheet in the last video. The first two using the addition-subtraction principle, and the next two using the multiplication-division principle. For the remaining problems, we're going to have to apply both principles, and in many cases, both principles multiple times. So let's look at number 5. And I'm going to do number 5 two different ways because I really want to stress the fact that when you see someone's solution, whether it be mine or someone else's, whether it's something you see or watch or read in a solutions manual, you're looking at a solution to a problem, not the only solution. So whenever possible, I'd like to offer multiple perspectives in terms of how to solve a problem. So for number 5, we have the equation 5 times the quantity 3x minus 1 equals 20. I'm going to write it twice because I want to solve it twice. 3x minus 1 equals 20. Now our goal is, as always, to solve for x. Now x is the variable that represents temporarily an unknown number. We just need to figure out what that number is. So we want to go through a sequence of steps and transform or rewrite or manipulate this original equation into the simplified form x equals some number. And once we're at this point, that's our solution, that's our value for x. We want to know what number, well, if we plug in for x, will give us a 20 on the left-hand side. Okay, so let me erase this. Now, there's a couple different ways we could start this problem, but essentially, when you look at a problem like this, there's an x that you want to isolate, and then there's the 5, the 3, and the 1 that we need to get rid of. We need to eliminate the 5, the 3, and the 1. That's how we're going to get x by itself. Now, the way in which we do that, there could be some variation. So I'm going to start off by looking at just the 5. So if I want to eliminate the 5, the 3, and the 1 one at a time, how can I get rid of this 5? Well, there's a couple different ways that we could do that. We can, well, that's multiplication, 5 times the quantity 3x minus 1. So the opposite of times 5 is divide by 5. And whatever we do to one side, we have to do to the other. And in this case, the times 5 and the divide by 5 will cancel. So we'll be left with a 3x minus 1 on the left. And then 20 divided by 5, that will give us 4. Okay, so we've eliminated one of the things around the x, and we have 2 more to go. Now we have to get rid of the 3 and the 1. Another way of starting this problem, also to get rid of that 5, rather than divide it out, we can distribute. So we can multiply 5 times 3x and 5 times the minus 1. In this case, 5 times 3x would be 15x, and 5 times the minus 1 would be minus 5. So these equations look different, but they will get us to the same place. Remember, it's not how we solve the problem that's important, it's that we eventually solve the problem. All right, so let's finish it up on the left now. Now we have this times 3 to get rid of and the minus 1 to get rid of. So let me just take this opportunity to point out a very common mistake I've seen many students make in the past. The general rule to solving algebraic equations, solving math equations. When you have an equal sign, and you have a left side and a right side of that equation, you can change one side in any way you want as long as you change the other side in the same way. The key word there is side. So if you look at that times 3, that 3x, and say, okay, well, to get rid of a times 3, I should divide by 3. And that means over here on the right, I have to also divide by 3. This would be incorrect because I haven't divided the whole right-hand side by 3. I've divided only the left-hand side, I've divided only part of the left-hand side. So if if your choice, and that's fine if you do, if your choice is to divide by 3, you have to divide everything on the left by 3 and everything on the right by 3. But that incorporates fractions into the problem, which is probably what we want to avoid. So rather than deal with the 3, let's deal with the minus 1. Okay, so back to the solution. The way to get rid of a minus 1 is to do the opposite, plus 1. Plus 1 to the left-hand side, plus 1 to the right-hand side. And in this case, the minus 1 plus 1 will cancel, and we're left with a 3x on the left, a 5 on the right. Now, to eliminate that times 3, we have 3 times x. To get rid of the times 3, we can now divide both sides by 3. The times 3 divided by 3 will cancel on the left, leaving x. And on the right, we're left with 5 over 3. And that's going to be our final answer. And if you remember, we started on the right-hand side. We started a different way, but we should get to the exact same place. If we have a minus 5 here, we can add 5 to the left-hand side, add 5 to the right-hand side. That will eliminate the 5s. We'll have 15x. And on the right-hand side, 20 plus 5 is 25. Okay, now to isolate the x, we have times 15. We want to reverse that. We could cancel that off with a divide by 15. So we'll divide both sides by 15. The times 15, the divide by 15, they cancel, and we're left with x by itself, which is what we want. And we have 25 over 15. And now, of course, always give your fraction in reduced form. And since 25 is 5 times 5 and 15 is 3 times 5, the 5 over 5 cancel because that's equal to 1. And again, we come to x equals 5 over 3. So I think it's important to note that almost always, unless it's a very simple problem, almost always, there are multiple paths to your solution. All right, so let's keep going. Number 6 on the worksheet, we have a 1/4 plus 4y equals 3y minus 7 over 16. So now we have the variable we're looking for is occurring on both sides of the equation. And so our goal is to, again, eventually go through a sequence of steps and end up with y equals some number. So to do that, the general approach is get all of your variables to one side and all of your numbers to the other. So we have this 1/4 on the left. Let's get rid of that. And then we have this 3y on the right. Let's get rid of that. So let's put all the y's on the left-hand side. Okay, so we could start the problem off by subtracting 3y from the left and a 3y from the right. That will cancel off the y's on one side. All right, so then we'll have a 1/4. 4y minus 3y, that leaves us with a plus 1y equals negative 7 over 16. All right, we want to get y by itself, so we have to get rid of this 1/4. The opposite of a positive 1/4 is a negative 1/4. So let's subtract 1/4 from both sides of the equation. And that will give us what we want. The positive 1/4, the negative 1/4 will cancel, and we'll have y is equal to, well, let's figure this out. Negative 7 over 16 minus 1 over 4. Well, to subtract two fractions, we need a common denominator. And in this case, the common denominator is 16. So we need to change this this bottom here, this denominator, to a 16, so we can multiply the top and the bottom by 4. If you want more details on how to do this, I posted a video in a previous week on adding, subtracting fractions. So if necessary, go back and watch or rewatch that video. All right, so that will change that second fraction. So we have a negative 7 over 16 minus, so this 1 over 4, if we multiply by 4 over 4, we'll have a 4 over 16. And now we have a common denominator, so we could subtract negative 7 minus 4, so it's becoming more negative. So that will give us a negative 11 on top, 16 on the bottom. All right, and that is our answer for number 6. All right, and the problems are getting progressively more challenging, or I like to say more interesting. So moving on to number 7. So now we have a 1/3 times 6x minus 15 on the left, and that is equal to 1/4 times 20x minus 8. Now, as we saw, let me scroll back up. As we saw with number 5, I showed this problem two ways. Dealing with the 5 on the outside first, or multiplying through the 5, distributing, and then canceling. And the same thing is true with number 7. We have options here. We can multiply through these fractions if we want, or we can eliminate those fractions, which is what I'm going to do. So in my solution, now again, this is my solution, not the only solution and not necessarily the best for everyone, but in my opinion, when I look at this problem, when there's an equation with fractions, I think the simplest thing to do is to get rid of those fractions. And one method that always works to eliminate all fractions in an equation is to multiply both sides of the equation by the common denominator, by the least common denominator. So if you look at the fraction, 1 over 3 and the fraction 1 over 4, between the 3 and the 4, the common denominator would be 12. And so 1 over 3 is equal to 4 over 12, and 1 over 4 is equal to 3 over 12. So the common denominator would be 12. So what we could do is multiply both sides by the common denominator. I'm just going to rewrite the whole problem, even though this is not absolutely necessary. But if we just throw a times 12 in front of both sides of the equation, 1 over 4, 20x minus 8. Well, if you're using a common denominator to multiply both sides, well then those fractions will always cancel off. This will become a whole number, and this will become a whole number. 12 times 1/3, or 12 over 3, that equals 4. And then we still have the 6x minus 15. And on the right-hand side, 12 times 1 over 4, or 12 over 4, equals 3. And we have the 20x minus 8. Now we can distribute and proceed as we did before. Now that we've eliminated the fractions, we can multiply through the 4 and we can multiply on the right through the 3. All right, so 4 times 6 is 24, so we have 24x minus 4 times 15, which is 60. And on the right, 3 times 20x, that is 60x. And 3 times a minus 8 is a minus 24. And as I said before, you want to get all your variables on one side. It doesn't matter which side, the left or the right. I like keeping the variables on the side that there's more of. So you have 60 x's on the right, 24 x's on the left. You have more x's on the right. So I'm going to keep the x's on the right, which means I want to get rid of the x's on the left. So we could subtract 24 x's from the left-hand side, subtract 24 x's from the right-hand side. So on the left, the 24 x's will cancel, and we still have this minus 60. And on the right, 60 minus 24 should be 36. So we have 36 x's on the right, and we still have that minus 24. And we're going to keep going. We want to get x by itself, so let's get rid of this minus 24. So we could add 24. So you see we're applying the same 2 steps over and over. To get rid of addition, use subtraction. To get rid of multiplication, use division, and vice versa. So the 24s cancel, 1 plus 1 minus. We have 36 x's on the right, and a negative 60 and a positive 24 will be a negative 36. Now we're one step away. We want x by itself. We have 36 times x. So the opposite of times 36, divide both sides by 36. And that should do it for this problem. The 36, the times 36, the divide by 36 on the right, they cancel. And we have x. And on the left, negative 36 divided by positive 36 should give us a negative 1. All right, so negative 1 is our answer for number 7. All right, a couple more to go. And for number 8, I think it's easier if I copy it over. Let's make that just a little bit bigger. Okay. So problem number 8. Now we have, there's a lot going on both sides of the equation. So before we start moving things from the left to the right or the right to the left, let's look at just the left-hand side by itself. So we'll look at just the left-hand side, and let's simplify that. And then separately, we'll look at the right-hand side, and let's simplify that. Meaning collect all the like terms and group everything. So we could start off by breaking up the parentheses, distributing. That's the minus 5.4 times both the x and the 3.6. And also distribute through the minus 3. So a minus 3 times x and a minus 3 times the 6. All right, so we've got 13.4 minus, now we have a minus 5.4 or a negative 5.4 times x, so that's minus 5.4x. And then we have a minus 5.4 times a positive 3.6. So that's going to be a negative number. A negative times a positive is a negative. And if you plug that into a calculator, you will have a minus 19.44. And then on the right, we have an 11. Then we have this minus 3 times x, so that's a minus 3x. And a minus 3 times 6, that will be a minus 18 or negative 18. All right, now we could combine some like terms. We've got two numbers on the right. We've got two numbers, or sorry, on the left, and we have two numbers on the right. So the positive 13.4, the negative 19.44, we could combine those two. And then we have this positive 11 and this negative 18. We could combine those two. So again, calculator, 13.4 minus 19.44. That will give us, according to the calculator, a negative 6.04. Okay, so we still have this minus 5.4x, and we combine our like terms, so we have a negative 6.04. Then on the right, positive 11 minus an 18, that will be a minus 7. So we have a minus 3x and a minus 7. All right, so now we can start thinking about moving the x's all to the same side. So if you want, we could add 3x's to the right, which means we have to add 3x's to the left. By adding those 3x's to the right, we have a negative 3x, a positive 3x, they cancel. So we're left with the negative 7 on the right. And on the left, a negative 5.4x plus a 3x. That will give us overall negative 2.4x. And we still have the minus 6.04. So our equation is getting progressively, step by step, simpler, more compact. Okay, so now we have 2 steps to go. We have to get rid of the 6.04 and get rid of the 2.4. So the opposite of the minus 6.04, we could add 6.04 to both sides. So on the left side, on the left-hand side, they cancel. So we're left with a negative 2.4x on the left. And on the right, we'll have a negative 0.96. One more thing to do, get rid of the times negative 2.4. So we do that with division. The opposite of times negative 2.4 is dividing by negative 2.4. Whatever we do to the left, we have to do to the right. Divide by negative 2.4, and that should do it. The times negative 2.4 divide by negative 2.4, they cancel. So we're left with x, and on the right, negative 0.96 divided by negative 2.4 is a negative, oh sorry, 2 negatives make a positive, so it will be positive 0.4. I think, let me just double check that with a calculator. Yeah, a positive 0.4. And that should do it for number 8. All right, so this is, again, we're applying the addition, subtraction rule and the multiplication, division rule in the same problem multiple times, each rule multiple times within the same problem. But if you, and before I scroll down, if you go through these problems methodically, step by step, and notice this is always how my work's going to look. I'm rewriting and simplifying in black, and I'm marking my steps in red. So it allows me to very clearly track what I do throughout the problem. All right, almost done. One more problem, and I think it makes sense to end with a more challenging equation than the previous equations have been. There's a lot going on in this one. All right, this is number 9. I'm going to proceed, because again, there's a lot going on, so we want to be careful and methodical in how we go through the problem. Before I deal with this equal sign. Before I start moving things from the left to the right or the right to the left, let's look at just the left-hand side. Simplify that as much as we can, and just the right-hand side, simplify that as much as we can. And then, so you could think about this as sort of like two separate things to do, and then once we've simplified each side, then we can start moving things around and canceling things off. All right, so when we're simplifying, we want to work inside out. So we could multiply through that -3. So we want to get rid of all the parentheses. We want to collect all the like terms, so we could use the distributive rule. So we've got a 3, then we've got a bracket, then we've got a 3. Now, -3 times x, that will be a -3x. And then we distribute the -3 times the +1. 3 times 1 is 3, so that's a -3. And there's a bracket, and there's a +1. All right, inside these parentheses, these brackets, we have a +3 and a -3. They cancel. So we have simply 3 times a -3. Oh, sorry, -3x plus 1. So now we could distribute this 3 on the outside. So that'll give us a -9x, and then we've got this +1 on the outside of the brackets. All right, looks good. So let's do the same thing to the right. We can multiply through that 2. So 2 times -14 should be a -28. And 2 times the -x, well, that's -2x. And then we've got a +2x and a +14. All right, so nice. Again, we have some canceling. We have a -2x and a +2x. So they cancel. And then we've got this -28 and this +14. So together, a -28, a +14, that gives us a -14. Okay, so we've simplified the left-hand side to -9x plus 1. We've simplified the right-hand side to -14. A much simpler, more succinct equation. All right, so we're only a couple of steps now to get x by itself. We got to get rid of the 9 and the 1. So we've got this +1 on the left. We can get rid of that with a -1. Whatever we do to the left, we do to the right. Subtracting 1 from the left means these 1s will cancel, leaving the -9x on the left. And on the right, a -14 and a -1, that gives us a -15. And finally, the last thing to do, to get rid of the times -9, we will divide by -9. And we'll divide both sides by -9. That should do it. The times -9, divide -9, they cancel, equal and opposite. On the left-hand side, we have an x. And on the right-hand side, -15 over -9. Well, two negatives cancel. So that's 15 over 9. 15 is 3 times 5. 9 is 3 times 3. Those 3's cancel. So our final answer is x equals +5 over 3. All right, so we've done quite a few problems in these two videos, and they've gotten progressively more complicated as we've gone along. I don't mean complicated in the specific individual steps, because the only thing we've done in all 9 of these problems is add something to both sides, subtract something to both sides, multiply something to both sides, or divide something to both sides. What makes these later problems more complicated is that it's happening a lot of times. We're doing a lot of steps within the same problem, so there's much more room for making a mistake. All right, so my first video of this week was setting up word problems. My current video that we're finishing right now is solving equations. Now we're going to take these two videos and sort of merge them together, and my third and final video for this week will be solving word problems. So that means setting them up, that was the topic of the first video, and then solving, which was the topic of this one. So my next video will be the full problem, read a word problem, convert it to a mathematical equation, and then solve that equation. All right, that does it for this video. This problem set is over. I hope it was helpful.